So far, I've just been executing commands at the command prompt in the command window. This is a really inefficient way to use MATLAB, especially when you start doing fairly involved multi-step calculations. If you make an error in one of your commands, you have to redo that command and any subsequent commands that depended on that one. This can be really tedious and time-consuming. It's usually easier in the long run for anything except the very simplest calculations to use a script file to execute your commands. A script file is simply a text file which contains the set of commands that you want to execute as a group. So all your commands are in the same file. You can change your commands and make corrections in the file and then execute the script file to redo the entire sequence of commands. This makes debugging a lot easier, believe me. Another nice thing about script files is that it's easy to save the set of commands you used. When you execute commands at the command prompt, the commands and your results are lost when you close MATLAB. This can make it difficult to reconstruct the results of an analysis. However, the script file is saved just like any other file, and it's always available if you need to redo your analyses. Script files are one of two different kinds of M files. M files contain a sequence of commands, generally called a program, which are executed by MATLAB. They're called M files because the file extension is an M. The two kinds of M files are script files and functions. The main difference between script and function files is that script files use the same workspace that's used when we execute commands at the command prompt. Technically, this is called the base workspace. Function files, however, each have their own workspace. This means that you can create variables in functions without worrying about whether these variables are overwriting variables that already exist. But that's a topic for a later video. When you run a script file, the commands in the script file are executed in the order in which they appear in the script file. Since script files use the base workspace, this means that the effect of the commands is exactly as if you had typed and executed them sequentially at the command prompt. So, any variables created by the script file are saved in the base workspace, and all the variables in the workspace are available for the script file to use. This means that you need to be a little bit careful about whether your script file is using any of the same variable names as the variables that are in your workspace. The script file will replace variables in your workspace that have the same name as the variables used by your script file. There are a couple of different ways to create and execute script files. You can use the graphical user interfaces or the command window to do this. The first approach I'll use in the demonstrations uses the GUIs, since a lot of students seem to like that approach. Later in the video, though, I'll do the same process using MATLAB's command window. I think that using the command window is a simpler, faster, and more flexible approach, so I'd advise you to at least try it. One way to create a script file is to click on the New Script icon on the Home tool strip. This opens an editor window. Just type the commands that you want to put in your script file. I'll type in a few random commands. For example, I'll set var1 equals 3, semicolon, var2 equals 2, semicolon, var equals var1 plus var2, semicolon, and finally my var equals cosine of var, semicolon. Keep in mind that the commands get executed individually in the order you type them in the script file. So make sure that you don't use a variable in your script file unless it's been defined earlier in the file or is already in the workspace. Now that I've created my script file, I want to run it so that my commands will be executed. Again, there are a couple of different ways to do this. The first way I'll demonstrate is to use the graphical user interface on the editor Windows toolbar. Before you can run the script file, it has to be saved to disk. You can save the file by clicking on the Save icon here. It gives you a fairly typical window prompting you for a location to save the file and a file name. I'm going to postpone saving the file for a minute though. Now, after you save the file, you can click on this Run icon and the file will execute. If you click on the Run icon without having saved the file first, MATLAB responds with the same Save dialog box that the Save button gave you. The Save window provides a default location for saving the file, but it's a good idea to choose for yourself where the file gets saved. If you just dump everything to a default location, you have very little chance of actually finding your work again when you need to. I'm going to go to the Tim folder on the C drive and create a new folder named Demo1 in that folder. Now I'll save the file as my Demo1 in that Demo1 folder. Now I get this message that the folder isn't on MATLAB's path, along with a few options of what to do about this. I could save it to a different folder with the Change Folder option, but I don't really feel like guessing where a folder on MATLAB's path might be, and don't really want to clutter up the folders that are already on the path. So I'm going to choose the Add to Path option. For a little clarification, the path is a list of folders where MATLAB looks for stuff. Now the folder where I saved my file is in MATLAB's path, so that MATLAB can find the file and run it, which it does since I clicked on the Run button in the first place. When it runs, the file name, the command I executed by clicking on the Run button, appears in the command window. And the variables created by the file are in the workspace. I can type who to see that. None of the values of the variables are displayed since I followed all of my commands in the script file with semicolons. But I can view the results of the calculations by typing the variable name and pressing enter. For example, to see the variable var, just type var and press enter. Another way to run the file is just to type the file name at the command prompt. So just for fun, I'll modify my file slightly. I'll set var to be var1 minus var2 and save the file by clicking on the Save button. Notice that I don't get a dialog box this time, since the file has a name and a location that's already on MATLAB's path. I'll close the file to show that it doesn't need to be open for me to run it, and clear the workspace by typing Clear All. I can check that my variables were cleared by typing who again. Now I can just type my demo1 at the command prompt. The file runs and puts my variables in the workspace. I can see that by typing who again to check. I changed the script file, so I should get a different value for var. Now, when I added the folder containing my file to the path, MATLAB automatically looks in that folder when asked to execute a command. You can check MATLAB's path with the path command. Just type path and press enter. These are all the places on disk where MATLAB looks for files when you ask it to execute a command. The folder I added to the path is right at the top of the list. However, I feel that having the editor window add folders to the path is not really the best way to work. For example, I'm going to close MATLAB and then reopen it. Now I'll try to run my file by typing my demo1 at the command prompt. Now MATLAB can't find the file. Let's check the path again by typing path. The folder I added to the path in my previous session isn't there anymore. The path got reset when MATLAB closed. I can reset the path again with the add path command, but I find this to be kind of irritating. So let's talk a little bit about where MATLAB looks for files, in what order, and then try to use an approach that takes advantage of that information. When you type a command in the command window, MATLAB goes through a specific path of locations when it tries to look for the command to execute. Knowing this sequence is essential when you're using MATLAB, since there's a chance that MATLAB will find an alternate way to do what you think you asked MATLAB to do. If you don't know what MATLAB's doing when you execute a command, it can be nearly impossible to understand what's going on and fix it. Anyway, first, MATLAB tries to interpret the command as a variable name and looks in the workspace for a variable with that name. If it finds a variable with that name, it returns the value associated with the variable. After that, MATLAB looks for a built-in function whose name matches the command. If a match is found, MATLAB attempts to execute that function. If neither of the above two conditions is met, MATLAB looks in the current working folder for a file whose name matches the command. If it finds a match, MATLAB executes the file. Finally, MATLAB looks through the rest of its search path, the list of folders I showed you previously with the path command. The search order is the same as the order of the files displayed by the path command. The first time a match is found, MATLAB stops looking and executes that file. I want to re-emphasize that MATLAB stops going through this list the first time it finds a match to the command. So if the command matches a variable name in the workspace, MATLAB stops searching for other conditions that could be satisfied and uses the variable it thinks you want. Taking into account the way MATLAB searches for stuff, I have a recommendation for how you create and execute script files. When you start a session or a specific problem or assignment, make your current working folder something that you will associate with that session. For most people, I think this simplifies the process of creating, loading, and saving files. Remember that the current working folder is the default location where MATLAB's editor saves files that you create. It'll also be the first place MATLAB will look for a script file you're trying to execute, assuming that you didn't accidentally give your script file the same name as a variable in the workspace or a built-in function. As a bonus, the current folder is also the default location where the load command will look for files, and it's the save function's default location for where files are saved. So if your session gets interrupted, it's very easy to save the contents of the workspace to the current folder. Then, when you want to resume work, go to the same current folder and load the workspace. Also, the current folder window displays the contents of the current working folder. So it's obvious from MATLAB's desktop what files are in the folder you're working with. This way you don't have to go to an application like Windows Explorer or use the ls command to check whether the file you're trying to run is actually in your current folder. The current working folder is also the default location for file management commands like ls, mkdir, and rmdir, which makes those commands easier to use as well. Now I'll return to the demo and see how I'd use this to change the way I create and run a script file. First, I'll set up a new working folder. I can do this by clicking on the Browse button up here. I'll navigate to the TIM folder on the C drive. Inside that folder, I'll create a folder named Demo2. This folder is now my current working folder. Now I'll create a script file by clicking on the New Script button. I'll put a couple of random commands in the file. So test1 equals 3, test2 equals 4, and output equals test1 dot times test2. Now when I click Save, the Save dialog box defaults to the current working directory. MATLAB knows where this folder is, so I can just give the file a name. I'll call it test file, and click on Save without having to go through the whole process of choosing a location and making sure it's on the path. Then I can just click Run to run the file. The file executes and the value of output is displayed, since I didn't follow that line with a semicolon. I can also run the file by typing the file name in the command window. As I did in the last demo, I'm going to clear the workspace by typing clear space all. I'll close the editor. Now if I type test file, at the command prompt, the file runs and I get my result. Now I'm going to try closing MATLAB again and reopening it. If I want to resume my session, I just set the current working folder to the folder I was using before. I can use the Browse button, as I did before, or usually I can just select the folder from a list of recently visited folders by clicking on this down arrow. Now my current folder window shows the script file I was using before. I can run the file by typing its name in the command window. So I'll type test file and press enter. I can also edit the file simply by double-clicking on it in the current folder window. So I'll change test2 to 24, save the file, and rerun it from the command window. So next, I'll use commands typed at the command prompt to perform these tasks. This can be especially useful if I want my script file to, for example, create a folder and save some data in that folder. I can put these commands in a script file, but I don't know how to tell a script file how to click on an icon. First, I'm going to go back to the TIM folder on the C drive. The TIM folder is the parent to the current folder. I can move to this folder by typing cd space ... Remember that ... is the name of the parent folder of any current folder. Now I can create a folder named demo3 in the TIM folder by typing mkdir for make directory, a space, and demo3. I'll check that the folder got created correctly by typing ls. Now I can make demo3 my current working folder by typing cd space demo3. I can create a new file in that folder named new demo by typing edit space new demo at the command prompt and pressing enter. Yes, I do want to create the file that I told you to create, so click on yes or just press the enter key. The editor opens and I can type my commands in the file. I'll set a variable x equals 4, a variable y equals 7, and calculate a variable z equals x divided by y. I won't follow this final command with a semicolon so that something will display when I run the file. Now I can save the file by clicking save. Notice that the file's already been given a name by the edit command, so I don't have to deal with that dialog box either. Now to run the file, I just type the file name at the command prompt, new demo, and press enter. And I hardly had to use the mouse at all, except to click on the Save button in the editor window. Now that I've shown you a few ways to create and execute script files, you can choose whichever approach you prefer. In my demos in these videos, however, I'll tend to type the commands rather than use the GUIs for several reasons. Aside from the fact that I'm old and I'm stuck in the habit of using this method, I prefer this method because it better gets us in the frame of mind to use function files later. And since this method lets you do almost everything from within a script file, there's an almost complete record of everything that you do. Running a script file by typing the file name rather than clicking on the Run icon in the editor window is an approach that you can use to run one script file from within another script file. This lets you divide your programs into discrete modules, which can make your programming much easier. If you need a review of the commands used for file and folder management, the second video in Chapter 2 introduced the commands. The next topic relative to script files is comments. Comments are text, which is included in the file, but isn't executed by MATLAB. Comments are used to describe how your code works and document when and why it was created. Since script files tend to be around for a long time, comments are important to provide reminders of what the file does and how it works.